All right, to start chapter 6, we're going to start talking about polygons, and today we're going to learn how to classify polygons based on their sides and angles. And then the second part is to find and use measures of interior and exterior angles. And we've already talked about interior angles before, so we're going to add on exterior angles. So the first thing we need to know is figure out what a polygon is. A polygon, we've already talked about this a little bit, that a polygon is a closed figure with all straight sides. And let's see, straight sides. The sides cannot be intersecting. So if you have something that looks like this, that is not a polygon. And let's see, closed straight sides. Oh, it has to have more than 3 or more sides. So those are all the things that make up a polygon. Diagonal is something that goes from one vertex to another vertex. So this green line is diagonal, and the vertex is where two sides meet. So I think that's all the vocab you need to know. Some more things you need to know are all these names of the polygons. So if I put this on an exam, you have to know that a hexagon has 6 sides. So this is in your book. Find it, memorize it. First part on your homework, you're just going to tell if a figure is a polygon, and then name it by the sides. So for this one, we have all straight sides, and it's closed, and they don't intersect. So yes, this is a polygon. Same thing for here. Yes, this is a polygon. But then you have to name it. 1, 2, 3, 4, 5, 6. 6 sides. We have a hexagon. This one has 1, 2, 3, 4, 5, 6, 7. 7-sided polygon is called a heptagon. So those are both polygons. These ones, this one has curved, so no. This one is not closed, it's open, so no. These are not polygons. Try those ones. Alright, the second thing that we can talk about with polygons is whether or not they are regular or irregular. Regular means two things. It means that all the sides are congruent and all the angles are congruent. They both have to happen in order for it to be regular. If they don't both happen, then it's called irregular. Another way to classify polygons is about whether they're concave or convex. Concave, I like to remember it as like caving in. Or if you look at the diagonals, notice you're going from one vertex to the other vertex. If any diagonals are outside, that's called a concave polygon. If all the diagonals are inside, that's called a convex polygon. So the second thing you're going to be doing is, these are all polygons. You just have to tell me if they're regular or irregular, concave or convex. So let's think regular or irregular. Regular means, again, all sides congruent and all angles congruent. So if you look at this one, these ones have different angles, so this would be irregular. If you look at this polygon, all the sides are the same, all the angles are the same, this would be regular. If you look at this pentagon, all the sides are the same, all the angles are the same, so this is also regular. Now let's see if they are concave or convex. Remember, concave, they like cave in. Convex, they are all the sides are pointing outwards, all the diagonals are inside. So if you look at the diagonals in this one, they are all inside, so this would be a convex. Convex. Perfect. Same for this one. If you look at the diagonals, they're all inside, so this is also convex. And what do you think this one is? If you look at all the diagonals, they're going to be inside, so this is also convex. Oops. I don't know what I just did, sorry. And then for these ones, notice this one is caving in, so this most definitely is a concave polygon. And if you want to look at the diagonals, if you go from this vertex to this vertex, the diagonal is outside the polygon, so it's concave. Same thing over here. Most of you guys are going to say, oh yeah, all the diagonals are inside. Not true. What if you connect this vertex to this vertex? Then the diagonal is outside, so this is concave. In terms of regular or irregular, yeah, all the angles are the same, but are all the side lengths are the same? Nope. So it's irregular. This one, the side lengths are different, and the angle measures are different, so it's also irregular. So those are how to classify polygons. Something that a lot of people are having problems with are interior angles. To find the sum of interior angles, that means like if you add up all the angles, how much is it going to equal? So far, I think the reason why we get confused is because up until now we've been talking about triangles, and we know that the angles in all triangles add up to be 180 degrees. But now we're starting to talk about different shapes, like quadrilaterals are going to equal 360. What about pentagons? 540. There's a formula. The formula is 180 times n minus 2 is going to equal the sum of interior angles. So for a heptagon, hepta means 7, you would plug in 7 and then solve for there, and that tells you how many, the sum of their interior angles. And if I give you a question that looks like this is where people kind of get stuck. I want you to find the measure of each interior angle of a pentagon. So pentagon is important. That means it has 5 sides. So that means if you plug in 5, you know that all these angles added up have to equal 540 degrees. So what you're going to do is you're going to add up all of these C's. And you're not going to set it to equal to 180. You're not going to set it equal to 360. You're going to set it equal to 540 and then solve for C. And I don't know what that number is. And then divide by that number. And that gets you what C is. Okay, and we've done this before. We did this before our mini DSAT. And what we haven't talked about yet are exterior angles. And in exterior angles, it's pretty simple. Regardless of if it's a triangle or a pentagon or a 100-agon, if you add up all the exterior angles are the ones that are outside, they always equal 360 degrees. So if I give you a question like this, find the measure of each exterior angle of a regular dodecagon. Those important words are regular and dodecagon. Regular means all the angles are the same, and dodecagon means, decagon. Do means 2, deca means 10, so 2 plus 10, dodecagon has 12 sides. So if it has 12 sides, that means it has 12 exterior angles, and they're all the same. And we know for exterior angles, they add up to be 360. So just divide it by 12, and you'll get each angle is, what, 30 degrees? Yeah? Cool. Nope, not talking to you. Sorry. The last example is this is not a regular polygon, but we can still do the same thing. You know that if you add up all the exterior angles, they equal 360. So what you're going to do is add up these r's. 8r and 4r is 12r. 7r and 5r is 12r. So we have 24r equals 360. Divide by 24, and that'll tell you what r equals. Hooray!